I'm Anil Kumar. Welcome to my series on pre-calculus. We'll discuss a test paper on rate of change in this particular video. We have 12 questions. 3 of them are communication questions. The rest are knowledge, thinking and application questions. Let's begin with the very first one, which is consider several linear relations, horizontal, vertical, and those that are neither vertical nor horizontal. Discuss the average rate of change for each type of linear relation. So linear relations means they represent a line on a graph. So you could have a horizontal line, right? You could have a vertical line. You could have a line which is rising, or you could have a line which is falling. So these are your 4 cases which you need to discuss, and we're trying to figure out what is the average rate of change, right? So the average rate of change in each case, in this case, is equal to 0, right? Since we're considering any 2 points, and basically we're trying to find the slope, right? So you can use m equals to y2 minus y1 over x2 minus x1. In this case, the change in y is 0, therefore it is 0. Now in this case, if I consider 2 points here, in that case change in x is 0, and therefore the average rate of change here is undefined. You can say infinitely large, correct? Because the denominator which we are writing here, see, delta y over delta x is 0. Here average rate is 0 since delta y is equal to 0, correct? Now in this case, when we have a line which is vertically upwards, you see we have rise over run, so it is positive. So the average rate of change in this case is constant and positive. And in this case, the average rate of change is constant, however, it is negative. Right? Since the rise over run, so the rise here it is constant positive since we are going up, right? As we go towards rise over run. In this case, you have to always see from left to right, we come downwards, so that is negative. Do you see that? And moving right is positive. So their ratio becomes negative. So I hope that is clear. So for any line, we do have a constant rate of change, but for a vertical line, which is also not a function, we have undefined rate of change. Question number 2. On a speed versus time graph, what indicates that there is no change in the displacement as time increases? So we're talking about speed versus time graph now. So let us say speed velocity, let me write v here, and time t. So on a speed versus time graph, what indicates that there is no change in the displacement? So obviously the velocity should be 0, right? So that means velocity is 0. That means object is not moving. So it is at the same place, right? So this implies that displacement is not changing. So I hope that makes sense. In any communication question, you need to explain to get full marks, right? Now here is the third question for you. I'd like you to copy this question, understand, and then sketch the graph. Question number 3. Sam leaves his house to go for a run. He ran at a constant speed for 30 minutes. The path sloped upwards, so he slowed down and ran for 20 minutes. At the top of the hill, he returned to his initial speed and ran for another 15 minutes. he stopped for 10 minutes to rest. Finally, he ran at a constant speed, highest of the day, for 40 minutes, and then stopped. Sketch a graph for Sam's speed versus time and a graph of distance traveled versus time. So in this particular case, we have to sketch two graphs on the given information. One is speed versus time, and for the same speed versus time, you have to sketch distance traveled versus time, right? You have liberty of choosing your scale, the velocities and all those things, right? So let us see how to do it. So I'll kind of create a graph paper here. Let's say that is my vertical axis on which I'm going to plot velocity or speed, and let's say this is the time. Time, we'll keep it in minutes. On this side, we are going to plot distance with time. So let's think about velocities first, and then we'll translate the data on the graph. So it says Sam leaves his house and go for a run. He ran at a constant speed for 30 minutes. So we have to select what speed. So we can say for 30 minutes, let the speed be, we'll multiply that by some speed. Let us assume for easy calculation that the speed is 10. Correct? So we'll make a kind of a table where we'll have time, and that is velocity. And when you multiply time and velocity, you get distance. So we'll kind of create a table as we move along. So that is the most efficient way of doing such questions. So if your velocity is 10 and speed is 30, distance covered will be, multiply them, you get 300. So what we have assumed here is that the velocity is in meters per minute. Correct? We are taking 10 as our velocity, so we'll take a scale which is like 5, 10, let's say this is 15, and 20. Okay. And for 30 minutes, so on this side, let's take a scale which is like 20, 40, 60, 80, 100, 120. So when I say in 30 minutes, he runs with a constant speed of 10, on the graph, it will be a horizontal line, right? So this is 30 for us, so it will be a horizontal line. That is the constant speed for 30 minutes. Correct? So this is at 30. Now the next point here is he slowed down and ran for 20 minutes. So 20 minutes, speed will decrease it to 5, and when I multiply, I get 100. Correct? Now, as far as these times are concerned, easy to calculate for us. We have now the speed for 15 minutes. That means total time is 50. So here we are at 50. And that is where it ends. So we can say this comes down to this level. Correct? So we are at 50. So it's a good idea to also write the time and the distance and the speed together. So we could write here, which this can help us to plot the next graph. So we'll write here time with distance. We'll use time and distance in this graph. So first is 30, distance is 300. Now the time is 50 and the distance is 400. Distance from starting, which is going to be this place in the next graph. Correct? Okay. At the top of the hill, he returned to his initial speed and ran for 15 minutes. Then for 15 minutes, initial speed is 10. So we're going to multiply this. We got 150 as the distance covered. So time is 15 more. So we can say 65. and distance is 150 more, so 550. He then stopped for 10 minutes. That means 10 minutes. Stop means 0. So that is 0. But the time went by, so 75 and 550. That is very important. Finally, he ran at a constant speed, highest of the day, for 40 minutes. So for 40 minutes, highest of the day. So let's make it 15. And when you multiply 40 by 15, you get 600. So we'll add 40 to this. So 4 means 115 and 6 means 1150. So that becomes the time, and then stopped, and then that remains constant, right? Okay. So based on this, we can now sketch our velocity time graph. Time is in minutes. Okay. So we were already here at 5400. 20 minutes, 500. So that is where it is. Next 15 minutes, 150 is the distance covered, but 15 minutes we are only traveling at the speed of 10, back to 10. Okay, so back to 10 for 15 minutes, which will take you to 65. So 65 is here, so we'll go up and back to, so that is at 65. Now for 10 minutes, is at rest. That means 65 to 75, it is rest. Okay, so scale, okay, so let it be rest here. So let's say this is 75 for us, okay? And then for 40 minutes, he ran at speed of 15. So then goes back, and this shoots speed for 40 minutes. So time will be 115, and this is the top speed, correct? So that is at 50. Is that clear to you? So that is how we are going to sketch velocity and time graph. So on a proper graph paper, this will be more accurate. Right. Now on the distance, we can take distance in meters and time will be in minutes. And as we see, we want to go for 1150 meters, more than a kilometer. So let's make the scale. So we have this as, let's say 200, right? Let's say 200, 400, 600, 800, so 1000, and let's say this is 1200, correct? On this side, time, we'll just keep similar, 20, 40, 60, 80, 100, 120, right? In minutes. So we have our coordinate points, and that is why we spent so much time earlier to calculate all the things. Once you have the calculation, it is better to graph. Now, distance starting is 0. So the first point is 3,300. So that's your first point starting from here. So it's kind of here. So we can plot this 3,300. And then 5,400. So at 50, we are reaching the point 400, which is here. So on this line. So 5,400. And then we have 65, 550, 65, 550, somewhere there. So that goes. And at 75, again 550. So at 75, it is same distance, since the object is at rest. Sam is not running. And then at 115, it is 1150. So 115 is slightly less than 120, and that is 1150 right there. So that becomes the final run. And then it is constant. Do you see that? So that is how we could actually plot. All the relevant points are given in this table. So you could use this as your reference for giving the coordinates of each and every point if required. Okay. Final point is kind of very critical. So let's write this as 115, 1150. Correct? You could actually write all the points also from this particular table. 75, 550. Here we have 65, 550. And then we have 50, 400. And here we have 30, 300. Correct? So that gives you absolutely correct graph for distance versus time when you had assumed some velocities for the time duration given. So I hope that helps. Now let's move on with knowledge-based questions on rate of change. Question number 1 here is, at x equals to 5, the function f of x equals to 13x minus 1.3x squared plus 7.3 has a maximum, a minimum x-intercept on neither of the above. So well, whenever you're given a quadratic function, let's first rewrite this as in standard form, which will be minus 1.3x squared, right, plus 13x plus 7.3, correct? So that is your function. Since we have minus 1.3x squared, that means the parabola is opening downwards. So we could have a maximum in this particular case. Let's find where will the maximum be, right? So we know that maximum will be at minus b by 2a, right? In our case, the value of b is 13. 13 divided by 2 times minus 1.3, which is 13 divided by minus 2.6. And that is indeed minus b by 2a. There was minus here also. So minus and minus becomes positive. So we do get 5. So at this point here, it is at x equals to 5. So at x equals to 5, we do have a maximum. Is that clear to you? Correct? Question number 2. Which of the following function has negative rate of change at x equals to 2? Negative rate of change means the slope will be kind of coming downwards, right? So if you, that is x squared minus 2. We are looking at x equals to 2. So here at x equals, this first one is a parabola which is opening upwards. Now at 2, the slope will be positive since 2 will be on the right side, so not negative. Now in this equation, which is the second one, it again opens upwards, right? So it again opens upwards, and here the vertex is at minus 3 and minus 2. Now since 2 is on the right side, it is positive slope, so that is not right. In this particular case, we have x at 3. So this is also a parabola which is opening upwards. Sorry, this is at minus 3, right? So, but this one is at plus 3. So this is a parabola which opens upwards. And here the vertex is at 3 and 2, right? Now, since it is opening upwards, on x equals to 2 will be on the left side, so that is the right answer, correct? We have a negative rate of change. Now here, this last one here, it has a vertex at 2 itself, so we have a horizontal rate of change in this case. So only negative for part B, clear? So by a rough sketch, you can actually figure out. Let's see question number 3 now. The population of a town is modeled by P of t equals to minus t squared plus 12t plus 4, where P of t is size of population in thousands and t is the number of years since 2000. What is the average rate of change in population size from 2005 to 2010 in thousands per year? So basically we need to only calculate P of 10 minus P of 5 divided by 10 minus 5, correct? So let's calculate and find the answer. So P of 10 will be within brackets, let's write 10 square plus 12 times 10 plus 4. So we get here 24 minus. Let's change this 10 to 5 now. And that is equal to 39. Divide by 5. So when you do 24 minus 39 and then divide by 5, you get a value which is minus 3. So the answer is minus 3, which is our option B. 4. The population of a town is modeled by the same function, where P of t is the size of population in thousands and t is the number of years since 2000. In which year is the population rate of change 0? So this is a parabola, right? So which we expect to be like this. So we're trying to find the vertex. So as we did earlier, this 0 will be at minus b by 2a, right? So 0 will be at minus b by 2a, which will be minus of 12 divided by 2 times minus 1, which is 6. So 2006 is the right answer, correct? So this is the fastest way of answering these questions. Question number 5. What is the average rate of change of this function on that interval? So basically again find g of 3 minus g of 1 divided by 3 minus 1. So let's find g of 3. So I'm writing 3 for x. So we have 3 squared minus 4 times 3 plus 7. And that gives you 4. Minus g of 1. So basically we have 1 minus 4 plus 7. And that is 4. Well, so we get 4 and 4, which is 0. And so we get this answer as 0. So option C is the right option. Now, okay, 6. Estimate the instantaneous rate of change of this at its zeros. So first you have to find the zeros, right? So let's find the zeros for this function. Factor 4 times 1, so we get x minus 4 times x plus 1. So we have 2 zeros here. Now we need to find the instantaneous rate of change at 4 and at 1. So how will you find it? Well, different ways. One, we can have a general solution for this, and then in that solution we are going to substitute 4 and minus 1 to find both the rates of changes, correct? So difference quotient method can be applied. So let's do that difference quotient method, which will be f of a plus h. So there's less space here. Let's calculate f of a plus h, which will be a plus h whole square minus 3 times a plus h minus 4, right? Which is a square plus 2ah plus h square minus 3a minus 3h minus 4, correct? Now, from this function, you have to take away f of a. F of a is x square minus 3, sorry, a we should write it, 3a minus 4. And then we have to divide by h, right? So if I find, because there is less space, let me write down here, f of a plus h minus f of a. In that case, these 3 terms will cancel from here. So which are basically these 3 terms, right? They will cancel. You're left with the terms which have only h in it. So we have equals to, let's divide this by h also. And then we can take h common, right? So we have 2a plus h minus 3, correct? Over h. So this h and h cancels. Now since h is very small, we get the rate of change as 2a minus 3. Is that clear to you? So you have to do this, show this work. There's less space, so I'm doing it in shortcut. So at any point be 2a minus 3. So one of the point is 4, the other one is 1. So if I write 4 here, so the rate of change, let me write down here, or let me just push this page a bit. So let's write f dash at 4 will be equals to, substituting 4 here, 2 times 4 minus 3, which is 5. And then we'll substitute f dash minus 1. So 2 times minus 1 minus 3, which will be minus 5. So we get plus minus 5 as our answer. Is that clear to you? So that is how we can actually find the instantaneous rate of change. Well, it definitely requires more space to do, but I hope you have understood. We use difference quotient method, right? So use difference quotient method. So we found that the general rate of change was at any point A, you can write, well, if I write x here, is 2a minus 3 for x equals to a, correct? And then we substituted the value and found the answer. So I hope that makes sense. Let's move on and take the next question now. Question number 7. Consider the function f of x equals to x squared plus ax plus b. Determine the sum of the values of a and b so that the function has minimum at 3 and 9. So here, instead of using rate of change, we can actually find a function with minimum at 3 and 9. So minimum at 3 and 9 means y equals to, x coefficient has been taken as 1, so let's write x minus 3 whole square plus 9, right? So let's expand this. So we get x square minus 2ab gives us minus 6x, 3 square, which is 9, right? And this is also plus 9. So that gives us x square minus 6x plus 18. So if you compare with the given equation, we know that a is equal to minus 6 and b is equals to 18. We want to find what? Sum of the values, right? We want sum of a and b. So a plus b will be equal to minus 6 plus 18, which is 12. So A is the right answer, correct? Now let's look into part question 8. Which of the following function has the greatest average rate of change of interval between these points, minus 3 and minus 1? Well, all are transform square basic root function, x square, right? So if you have x square functions, the rate of change, this is at 0, right? This point here is at 0, 0 for all of them. Now, minus 3 minus 1 is on this side, somewhere on this side, right? So let's say somewhere here. Now, we're looking into this rate of change. So it will be maximum for where the vertical stretch is maximum. So option C, 3 is your vertical stretch. So that should be your answer, correct? Question number 9. Consider the function 3x squared plus ax minus 7. Determine the values of a so that the average rate of change of the function f of x on this interval is 8. Okay, so basically we are saying that f of 2 minus f of minus 1 over 2 minus minus 1 should be equal to 8. This is what we are saying, correct? So let's substitute the values and find the answer. So if I substitute 2 here, then what do we get? 4 times 3 is 12. 12 minus 4 is 8. So we get 8 plus 2a, right? 8 plus 2a minus. If I substitute minus 1 here, I get 3 minus 1 is minus 1. And we get minus a minus 1 divided by, this becomes 3. That should be equal to 8. Is that clear to you? All right. So we can now simplify this. So when you open the bracket, so you get 3a and 9. So we get 9 plus 3a, and let's cross multiply 24. So that means 3a is 24 minus 9. Right, so we get 3a equals to 24 minus 9. So 3a is equal to, so 15, right? So a is equals to 15 divided by 3, which is 5. So C is the right option. Is that clear to you? So we moved from this place to this place and then came down. Okay. Question number 10. The speed versus time graph shows a segment from 34 to 86. The units of the vertical axis are meters per second and the time is in seconds. If the object whose speed is being graphed is 12 meters away from the point from which measurements are made at t equals to 3, how far away is the object at t equals to 8? Okay. So just think about it. So we'll make a rough sketch again to understand the scenario. What is given to us is that we have 2 points here which are 3, 4 and 8, 6. Let's say this is our 3, 4. 8, 6 is, let's say, somewhere here. Okay. So these are the 2 points. Okay. Now, this is on velocity versus time. We want to find the distance traveled during this time, right? So it is, before that, the object has already traveled 12 meters. So we are now interested in finding this distance, which is the area of this portion, correct? To find the area, we can actually make you can use a trapezoid and find the area also. Okay. The points are 3, 4 and 8, 6. Okay. So I'll consider this to be, let's say this is 3, this is 8, so we have 5 here. And this height here is 4, so this height is 2. So you'll find area of this shaded portion, correct? So area of shaded portion will be 5 times 4, which is this rectangle, right? Plus half of base is 8 minus 3, 5, and height is 2. Okay, so that means 5 times 4 is 20, and this is 5. So plus 25. So total distance is 12 plus 12 is already traveled, and 25, which is 37. Okay, so option C, which is 37. Is that clear to you? So this is a very tricky question. I like you to really go through this question once again, try to understand, and then solve it, correct? Okay, so that's the communication part where we began. So I hope you have understood all the concepts. So we have done the communication, thinking, and application questions. With this, we come to an end of our test on rate of change. There were indeed very good questions in this test paper. I hope you understand and appreciate them. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.